The global economy just felt a major jolt after the White House announced tariffs of up to 145% on Chinese electric vehicles and critical materials. But while others scramble, Tesla's already ahead of the curve. As Elon Musk explains, something that's been a focus for Tesla for several years is to localize supply chains. Does this actually make sense from a cost standpoint? And from a logistics risk standpoint, it is to have the supply chains at least located on the continent in which the car is built. And so, we are, I think, the least affected car company with respect to tariffs. No Chinese graphite, no rare earths, no lithium refined overseas, starting at under $13,700 and built 100% in Texas. This car is Tesla's declaration of independence from China, and also a blueprint for affordable EVs made in America. In short, Tesla solved the problem before it even exploded, and in today's video, we're breaking it all down: what's happening, why it matters, and what's really inside the Model 2. But before we dive in, make sure you've hit that subscribe button to help Westech reach 37,587 subscribers, and tap the notification bell so you never miss the tech that's reshaping the future. Why Texas? Is this a strategic manufacturing move? Tesla has strategically chosen Giga Texas as the production hub for the 2025 Model 2, marking a major shift away from manufacturing in China and other parts of Asia. This decision comes at a critical time, as the White House has announced steep new tariffs of up to 145% on electric vehicles and essential EV materials imported from China. By manufacturing entirely in the United States, Tesla avoids these harsh penalties and saves thousands of dollars on each vehicle produced. Beyond tariffs, producing the Model 2 in Texas allows Tesla to slash logistics costs significantly. Building cars directly on American soil eliminates overseas shipping, port delays, and customs duties. According to internal logistics data, localized production can cut transportation and import-related expenses by up to 30%, critical for reaching a target price under $13,700 without sacrificing quality or margins. Giga Texas itself is one of the largest and most advanced factories in the world. The facility spans over 10 million square feet of floor space, making it even larger than Tesla's Fremont factory in California. It's designed to reach a maximum output of over 1 million vehicles per year, with production lines capable of building one vehicle body every 45 seconds. That speed is essential for delivering mass volumes of the Model 2, which is expected to be one of the best-selling EVs globally. At the heart of this productivity lies Tesla's revolutionary Giga casting system. Massive aluminum casting machines can mold the vehicle's front and rear underbody in single pieces, replacing up to 400 separate components per section. This not only speeds up production by 40%, but also improves structural integrity and cuts costs on parts and labor. Fewer robots, welds, and bolts mean faster assembly and fewer chances of defects. Tesla also employs one of the most automated assembly lines in the industry. Elon Musk's goal of an alien dreadnought factory is beginning to materialize in Texas, where over 80% of the production process is automated, drastically lowering labor costs while maintaining high output and precision. This advanced level of automation allows Giga Texas to produce hundreds of thousands of vehicles with just a fraction of the workforce needed in a traditional plant. Equally important is the local economic impact. Giga Texas has already created over 20,000 direct jobs and supports tens of thousands more through its US-based supply chain. This has gained strong support from American policymakers, as Tesla's approach directly aligns with the government's push to bring manufacturing home and reduce dependence on China. Do you think this marks the end of cheap Chinese EV dominance in the US market? Comment Tesla wins if you believe American-made EVs are finally taking back control. Which Chinese materials are being replaced? Why does it matter now? The Tesla Model 2 is a powerful declaration of independence from China's grip on the global EV supply chain. For years, key raw materials used in EV production have been heavily dependent on imports from China. But now, taking the trade war into consideration, Tesla's decision to pivot away from Chinese-sourced materials has become not only smart, but essential. Let's break it down. First, graphite, the single most critical material for anode production in lithium-ion batteries, is overwhelmingly controlled by China. Roughly 70% of the global graphite supply originates there, and most of the refining capacity is also based in Chinese factories. To counter this, Tesla has already begun sourcing synthetic graphite from partners in the United States and Canada, ensuring long-term price stability and supply chain security. Second, rare earth elements, especially neodymium, have been a cornerstone of EV motor technology. These materials are used in permanent magnets for brushless electric motors, which are highly efficient but deeply reliant on Chinese supply. China currently controls about 85% of the world's rare earth market, both in terms of mining and processing. In response, Tesla is developing and deploying next-generation magnet-free motors in the Model 2, similar to the design used in the newly refreshed Model 3. These motors eliminate the need for rare earths altogether, a major win for both sustainability and geopolitical independence. Third, lithium hydroxide, which is essential for high-performance batteries, is still mostly refined in China, even though lithium itself is mined in countries like Australia, Chile, and the United States. Tesla is actively supporting domestic refining initiatives and has entered agreements with North American lithium producers to localize both mining and refining processes. This shift is crucial, as the White House now applies tariffs as high as 25% on battery lithium compounds processed in China. How can Tesla Model 2 reach a game-changing low price? Tesla's ability to price the Model 2 as low as $11,750 to $13,750 is not a marketing gimmick. It is the result of a calculated strategy rooted in two key decisions: localizing production at Giga Texas and cutting reliance on Chinese-sourced materials. These moves are not just symbolic. They have direct and measurable impacts on cost reduction. First, by manufacturing the Model 2 in Texas, Tesla eliminates costly import duties and long-distance shipping fees associated with vehicles or components sourced from Asia. For reference, importing a vehicle from China can incur tariffs of up to 25%, while transporting heavy EV batteries across the Pacific adds hundreds of dollars per unit in logistics costs. By producing everything domestically, Tesla saves an estimated $1,200 to $1,800 per vehicle right off the bat. Second, the use of US and Canada-sourced materials like synthetic graphite and lithium refined domestically further lowers costs. Thanks to the US Inflation Reduction Act, IRA, Tesla can access federal incentives and tax credits for using American-made battery components. These subsidies can amount to $3,750 per vehicle for battery materials alone, plus another $3,750 if the final assembly occurs in the US, totaling up to $7,500 in savings per eligible car. Additionally, Gigatexas benefits from industry-leading manufacturing innovations such as gigacasting and high-efficiency automation. Megacasting allows Tesla to replace 70 or more individual parts with a single, massive aluminum piece for the front and rear underbody. This not only reduces material and assembly time, but also cuts structural costs by 10 to 15%. Combined with a highly automated production line powered by AI-driven robotics, Tesla expects labor and overhead expenses to drop by as much as 20 to 30% compared to Model 3 production. Altogether, these factors enable a total production cost reduction of roughly 25 to 30% over the Model 3, which currently starts at around $38,990. The Model 2's base cost is down to a revolutionary $11,750 to $13,750 without sacrificing performance or quality. This price point undercuts nearly every competitor in the US market, including Chinese EV brands like BYD or NEIO, which are now at a disadvantage due to rising US tariffs and limited domestic infrastructure. Is $11,750 to $13,750 for a Tesla the tipping point America needed? Drop Model 2 if you agree, or comment your dream price below. 4. What's inside the Model 2? Rare, earth-free motor. High performance without dependency. The Model 2 is equipped with an advanced permanent magnet motor that completely eliminates the need for rare earth elements, such as neodymium. Tesla's engineering team has developed a next-generation magnetic architecture that delivers strong acceleration and regenerative braking without these rare earth materials. The result is a powertrain that's not only geopolitically independent, but also more sustainable. Early estimates suggest the Model 2 will achieve 0 to 60 miles per hour in approximately 5.7 seconds, which is competitive for its class, while maintaining low energy consumption per mile. Structural lithium-ion battery pack. Lightweight strength with long range. The Tesla Model 2 uses a structural lithium-ion battery pack that serves two purposes. It's both the energy source and a load-bearing part of the car's chassis. This design eliminates the need for separate structural components under the floor, significantly reducing overall vehicle weight by up to 10% and contributing to improved acceleration, handling, and energy efficiency. Thanks to the integration of high-energy density lithium-ion cells directly into the vehicle's frame, the Model 2 achieves an estimated driving range of around 350 miles on a single charge. That's more than enough for a week of city commuting or a full day of highway driving without range anxiety. In terms of lifespan, Tesla expects the battery to retain over 80% of its original capacity even after 300,000 miles, with minimal degradation. Furthermore, it supports ultra-fast charging, reaching 80% capacity in under 15 minutes at V4 superchargers. The structural battery also improves safety by strengthening the vehicle's underbody during impacts, enhancing vehicle rigidity and safety in the event of a crash, along with reducing manufacturing complexity, hence cutting production costs while boosting durability. Ultra-durable gigacast construction, fewer parts, lower maintenance. Tesla has revolutionized how the Model 2 is built, using single-piece aluminum gigacasting for both the front and rear underbody. This manufacturing process replaces hundreds of individual stamped and welded components with just two massive castings, reducing complexity and assembly time. The car's structural design now includes fewer than 370 moving parts, compared to more than 2,000 in a typical internal combustion engine vehicle. This not only reduces the likelihood of mechanical failures, but also simplifies service and repair. Maintenance costs are projected to be 30 to 40% lower over 5 years compared to similarly priced gasoline vehicles. With fewer joints and welds, the car is also more resistant to corrosion, vibration fatigue, and long-term wear, extending its usable lifespan and reducing the total cost of ownership. Senior-friendly, minimalist interior. Simple, clean, and comfortable. Tesla has taken a fresh approach to cabin design with the Model 2, especially keeping older adults and non-tech-savvy drivers in mind. The interior is intentionally minimalist, with clean lines, large font labels, and no cluttered buttons or switches. The entire dashboard is replaced by a single horizontal touchscreen mounted centrally, measuring 15 inches in size. This screen acts as the control center for navigation, climate, music, vehicle status, and more. Importantly, the layout has been simplified to require no prior knowledge of EVs. Icons are large, color-coded, and organized by function, and essential driving data is always visible. Voice command support has been expanded, allowing users to operate almost every function using plain English, including turn up the AC, call my son, or navigate to pharmacy. Redesigned user interface, UI. Easy to learn, easy to use. Tesla's new user interface in the Model 2 has been reworked for clarity and simplicity. The interface uses a grid-based layout with haptic feedback and adjustable contrast designed to accommodate drivers with poor eyesight or slower reaction times. Unlike older Tesla software, this version allows larger text sizes and custom color themes to enhance readability. A new, simple mode reduces the number of on-screen choices, focusing only on essentials like drive, park, lights, and wipers. Tesla reports that most first-time users can become comfortable with the system in under 15 minutes. Updates are delivered over the air, and users can opt into new features only if they choose, maintaining a stable and familiar environment. Optional AI-assisted driving. Freedom of choice for everyone. The Model 2 respects driver independence by offering full self-driving FSD and autopilot features as optional add-ons, not defaults. Many older or rural drivers prefer to be in full control, and Tesla ensures they won't be forced into automated systems. The standard version includes basic safety assistance, such as lane keeping, forward collision warning, and emergency braking, but all other AI features, like Smart Summon or Auto Lane Change, are completely opt-in. This approach lets drivers use as much or as little automation as they're comfortable with. Moreover, AI tools in the Model 2 have been tuned to act more conservatively in complex traffic, catering to risk-averse drivers. The Tesla Model 2 is a bold step toward independence. Built right here in America, it breaks free from China's hold on the EV supply chain. This new era of clean, affordable tech, designed for everyday Americans from young professionals to retirees, is ready to lead the world. The future starts now, and it starts with the Tesla Model 2. Thanks for joining me, friends. I hope to see you in the next one.